In this video, I'm going to show you how I built, in my opinion, the ultimate Volkswagen Bug sleeper. A sleeper is a car that is very high performance but looks intentionally stock or ordinary. Starting with a 1973 Volkswagen Super Beetle, I adapted the engine out of a 2009 Subaru WRX. Instead of a beater or patina look, I decided to go with a new car look and have the car look like it just rolled out of the factory in 1973. This Subaru engine puts down 517 rear wheel horsepower on E85, which is about 16 times what the original Volkswagen delivered. How the Volkswagen and Subaru donor car looked before they got thoroughly molested. The first thing to do is do what we do best and just tear everything all apart. The Subaru all-wheel drive transmission has to be precisely cut, trimmed with general hackery to become a two-wheel drive unit. The floor pan has to be first modified so that the transmission moves 4 inches in front of the torsion tube. A temporary truss is welded in to support the torsion tube while work is being done. With the transmission as general location, the shifter linkage was made. Using a one-piece splined puck cut in half, the two pieces were welded into the housing so that shorter 21 3/4 inch torsion bars could be used. Let's make some motor mounts and box in the part that was cut away in the frame horn section. Since we removed all of the structure out of the original torsion housing, let's make some trusses out of 4130 plate. The rear motor mounts are made from 1/8 inch chromoly steel and, like everything else, are TIG welded together. And here's what the motor mounts and trusses look like on the pan. Another view of the shift linkage. Using 1 3/4 by 120 chromoly tubing, the frame horns were redesigned. The original clutch master cylinder from the Subaru was used and joined to the VW pedal assembly. The master cylinder now resides inside the tunnel. I originally used the seats from the Subaru, so mounts had to be made. Later, I swapped out the seats for lighter PRP seats. Since the direction of the Subaru trans is reversed, the ring gear needs to be flipped to the other side. Clearance is done to make room for the new ring gear location. To fit 275 50-15 drag radial tires under stock fenders, the torsion housing was narrowed 2.5 inches per side. The spring plate mounts on the swing arms were moved inward to match the torsion housing dimensions. The arms were also strengthened using internal gussets and external tubing. What the narrowed structure looks like now. Rack and pinion steering from a 1975 through 79 Super Beetle was adapted. Here the clearancing and subsequent strengthening of the pan needed are shown. In the first pic, you can see the 1-inch port where the hydraulic clutch line enters the pan. To direct the coolant towards the radiator, the water pipe needs to be reversed. However, it can't be reversed, so more fabrication and welding is done. Fuel lines, brake line, and finally powder coating is done to the pan, and boy does it look nice. Making rear caliper mounts to be used with 2000 through 2006 VW Golf calipers. Starting with the original Volkswagen backing plate, I then fabricated 3/16 plate and used a slip roller to make the U shape. Looking down from the top, you can see the 14-degree running angle the 930 CVs will run at constantly. And here the brake lines are added. We need to semi-tub the body for 11-inch tires. Like the torsion tube, the inner fenders had to also be moved inward. The 1-inch bar acts like a fixture to accurately locate the inner fenders 2.5 inches inboard. The motor and intercooler now reside in the luggage compartment, so room had to be made. 50,000's 3003 aluminum was used for the panels. The tools used to form the metal were a slip roller, bead roller, and shrinker stretcher. 134 solid rivets, or wait, was it 431? Anyway, a buttload of rivets were used to bind all the pieces together. Later, sealer will be used to fill in the gaps. You know, maybe it was 341, I can't remember. Since a lot of the body structure was removed, I built a tubular support specifically to position the rear bumper. To keep the weight down, I used 1-inch by 65 thousandths chromoly tubing. To aid in removing the engine, the rear apron was made removable. Going back to the front of the car, the rack and pinion had to be mounted to the body. This involved opening up the body on both sides so weld nuts could be welded in. The last photo is the powder-coated final of the previous work done to the pan to make room for the rack. Installing the radiator. The air intake for the radiator comes through the factory AC louvers. At this point, the air is fed through the radiator and then back down through the bottom of the car. The second, smaller cooler is the heat exchanger for the intercooler. The last photo is looking from the bottom up at the two radiator fans. Lifting and lowering the body with an I-beam and gantry crane. And other various photos I didn't know where to put. Using my trusty Duomite to bend lower brackets for the double adjustable QA1 race shocks. Holley Sniper in-tank retrofit fuel pump. A fixture was made to cut tubing to make a merge collector. It positions the tube at the correct angle to be cut and later welded using purged argon. A pipe expander is used to make the exit of the collector round. To make the exhaust header, I first secure the collector using a magnetic base. Then, equal lengths of welding wire is used to get a rough layout. Once all the tubing has been cut to length and tack welded, the header is brought over to a sturdy platform to be fully welded. The header is tack welded to the platform so that it doesn't shrink when welding. The coolant pipes are made from 1.5 inch 63 thousandths aluminum tubing. I use a bead roller to roll in the tubing beads. The intercooler hoses run through the tunnel, so manifolds were built to allow entry and exit of the hoses through the tunnel. I wired up the car but had a company called, ironically, iWire set up the standalone engine control system. The original fake exhaust tips I made, affectionately called pea shooters. When it comes to intercooler pumps, bigger is always better. To help the Subaru Trans survive over 500 horsepower, I made a chromoly girdle. The girdle also incorporates load bolts to keep the ring and pinion from having an argument. I also do some of my own powder coating. Now it's time to add a Kaffir bar to strengthen the frame horns. Drill the hole first, then bend, then cut. Since Subaru 5-speed transmissions are only good for about 400 horsepower, I switched to PPG dog engagement 1 through 4 gears. They are stronger in every way, but their customer service is terrible. The new low-mount turbo requires its own sump. I made this one out of stainless steel. When it comes to intercooler heat exchangers, bigger is always better. I didn't want to go with solid motor mounts, but instead went with super hard 90 durometer mounts. Since the rear seat can't really be used with a roll cage, I made a rear seat delete. You can also see where I put the Subaru immobilizer key. Using the biggest bell core that would fit, I made a water-to-air intercooler and subsequent steel tubular mount. New clutch and pressure plate to hold the newfound power. I switched to a low mount Garrett G25-660 turbo for better response. Let's make the stock looking pea shooter exhaust tips functional this time by using them to vent the wastegate. I decided to go with the color the car came with from the factory, which is Marina Blue, L-54. After 2 years, this project is finally coming to an end.